Alright, here's our first example. It says Prabhakar has just started to repay his student loan at $280 a month. His monthly statement indicates that he has 12 payments remaining, and the interest rate is 9.75% per annum. So this part here just means per annum, compounded monthly. If the bank will let him pay off his loan today, how much will he have to pay? Now, first of all, you want to think about whether this is a present value question or an annuity question. Okay, so first of all, I know that I'm looking at how much money he has today, and so that sort of indicates that you're looking at present value. But the fact that it says that he's paying off a student loan and that he is paying $280 a month tells me that this must be an annuity. Okay, so to figure out whether or not something is an annuity, the key word you're looking for is a regular payment. Okay, and a regular payment over a regular interval. So we know that she's making, or he's making, $280 payments, and we know that he's making it on a monthly basis. So I know this is an annuity problem. Okay, is this future value or is it present value? Well, because it's a loan, he owes that money right now, and he's making monthly payments of $280 to try to decrease the amount of that loan. Okay, so he owes the money right now, and so he's paying towards it to actually decrease the amount of this loan. So this is going to get smaller and smaller and smaller. Okay, so this is an example of a present value of an annuity. It's an annuity because he's making regular payments at regular intervals, and it's present value because he owes the money now and he's paying towards it so it can shrink over time. Okay, so let's start with the formula. And so this formula has 1 minus 1 plus I to the exponent negative n all over I. And if we look at the information we know R is equal to 280. That's the amount that he's paying on a monthly basis. I is equal to 0.0975. But he's got interest that is being compounded on a monthly basis. So I need to divide this by 12. And this is good because his compounding period matches his payment period. So he's making monthly payments and he's earning interest on a monthly basis as well. So let's find the value of I using the calculator. So 0.0975 divided by 12 gives me 0.008125. Okay, and the number of compounding periods, well, he's paying off his loan that he's got for a year, and he's paying off the loan 12 times a year since he's paying monthly. So that tells me he's making 12 payments a year, and we want to know how much he has to pay in a year. Or in other words, the other thing you can also look at is that it says that he has 12 payments remaining. So that tells me n is going to be equal to 12. So if I substitute in the information that I know, so I don't actually have to multiply anything here. If I substitute in the information I know, I have PV equals 280 times 1 minus 1.008125 to the exponent negative 12 all over 0.008125. So once you know the kind of problem that you have, and once you solve for the value of I and n, the rest of the question is pretty much substituting in the information that you know. Okay, so let's do this all in one step on the calculator to find the present value of the annuity. So 280 times bracket 1 minus 1.008125 to the exponent negative 12. Closing bracket, that's the value of the brackets here, divided by, so now that automatically multiplied it by the 280 that I have there, in case you're wondering where these numbers come from, divided by 0.008125, and that equals $3,189 and about 8 cents. Okay, so what that means is right now, if he was allowed to pay off his loan, he would be able to pay it off if he had $3,189.08. So he could pay it off right now and pay off $3,189.08, or he can just pay $280 a month for the next 12 months. Okay? So therefore, Prabhakar would have to pay $3,189.08 if the bank lets him pay off the loan today. Now, if we think about how much interest that he's actually paying the bank since he owes the money, and this is just a side question, if we think about how much interest he actually has to pay the bank, let's think about how much he's actually paying the actual bank and then figure out how much interest he's actually giving the bank. Okay? So, right now the present value of his loan is $3,189.08. That means this is how much he owes the bank right now. If he can't afford to pay this right now, then that means he has to pay the bank 12 payments of $280. So let's see what his actual payments are. So in terms of his payments, he's making 12 payments of $280. And so he's actually giving the bank $3,360. However, the present value of the annuity is $3,189.08. The difference between these two quantities is how much interest he's actually giving the bank. So this is how much he's paying the bank over the span of 12 months. This is how much he actually owes the bank right now. And the difference between these two numbers tells us how much interest he's giving the bank over the span of the year because he's not able to afford to pay off the loan right away. So $3,360 minus $3,189.08 gives me $170.92. So because he might not be able to pay off the loan right away, he actually has to give the bank about $171 in interest over a span of the year.